Go.
Hello!
Hello, say hello.
And hello, teacher. And today we're going to talk about something about class.
Okay, hello, Mr. Eric. Hello, Mr. Ryan.
Prefix sum.
Yeah. Okay, so what's class? Do you still remember? Object template, yeah?
Yeah.
Like person, and we remember we talked about a person, and then Eric equals person, yeah?
Yeah.
And Ryan equals person, yeah? Remember? Yeah, a little bit. Yeah, not too much. Okay, so today we talk about a prefix sum.
Prefix sum.
Prefix. What's prefix? Can you tell me what's prefix? What does it mean? What does it mean?
Something in spellings.
In spelling.
Yeah.
So can you give me an example? What's prefix?
Prefix and
What?
suffix.
Yeah, exactly. Suffix, yeah, well done, suffix. So prefix is that before, yeah? Before, yeah? Like a in English, what's pre means? Pre-calculate,
We do something, I don't know.
yeah, just before, yeah? It means the before, right? Alright, okay. So prefix sum is a very common used technique to speed up the
Speed up.
the calculation of sum of the interval. For example, if I give you a list of the numbers like 1, 3, 5, 7, 9.
9.
If I give you 2,
No, that's a 9.
okay, 9. Okay, if I give you this is a given nums, yeah, nums list, yeah. So if I give you a from and to, like if I give you a list of query like 3 to 4, inclusive, okay, this means inclusive, 4 to 5. So I want you to find out and all kinds of these query. I want you to find out that the sum.
3, 4, 4, 5.
The sum of this is the index. 3, 4 would be like 0, 1, 2, 3. 3, 4 would be 3 will be pointing to this. 4 will be pointing to this. So 3, 4 will be 7 plus 8 equals 15, right? 4, 5 is 17, right? So you could be like 0, 5. 0, 1, 2, 3, 4, 5. So it will be
9. No, 10.
no 1, 2, 4, 9. What? 16. 24, 33. So you get it? Yeah?
0, 5.
0 means start from the 0, the first
Why
place.
does it have
Yeah?
to be 33? Go up to 9.
Go up
Why
to
does it
9.
have to be 33? Oh.
Yeah, from 2. Let's appear from 2. So this is the index from 2.
Why does
So-
it have to be 33?
So the 0 is here. 5 is here. So what's the how the sum of these will be 1 plus 3 plus 5 plus. So how do you do that? I mean, without a prefix sum, you just can do it if this is the number.
Remember the thing when we do add all of the first all numbers, you just take away the 8, then you do all of those, which is 25, then add the 8. Easy!
Oh yeah, but look, we can do this sum equals 0, right?
Yeah.
So then we can do this for I in
Range.
Let's say it's in
Column!
no from 2
Oh.
plus 1, okay, from to 2. Then we do what? Sum equals plus nums I, right? Yeah? Alright?
Yes!
Yes?
Yes!
Do you understand? Now we are calculating the sum and put it in a variable as from the range from index to 2 plus 1 because this is 2, right? And this is the second parameter minus 1, okay? So we accumulate the value sum in this variable s. So what's the complexity?
O-N. 1.
No, you write the ON. Why you say ON? You keep saying this is the ON because look,
Yeah.
we need to. When you one tip of one tip is that when you see a 4, it's usually ON, right? Because
What?
when you see this 4, yeah, it's usually ON because you need to iterate those numbers, right? Yeah.
So every time you see 4,
90%, 99% maybe.
I want
You
to
get
read
it?
the number 4.
Look, when you see this, it's ON. Why? Because we need to iterate the numbers from at this range, right? Yeah? So this range are changed, so it means that it's on.
So it's only if we use the for I in range.
Yeah, and this is variable. This is input. If I tell you if this is for I in range 100, I in range 100, s plus equals I. What's the time complexity? 1,000 maybe. What's the time complexity of this one? Oh what?
N.
You guess?
Wait, just range 1,000. No. What's that word?
4. So this is ON. What's this?
O1.
O1, exactly. Why is that? Because this is constant. It never change. It means if I have a
1,000.
yeah, you can say 1,000, but we drop the constant. Remember we talked about this in the equivalent complexity, yeah? This is ON because N is actually equals 2 minus from, right? These two are changing. This is the input, so we cannot drop it.
Why is it O1?
O1, because this is constant. It means that no matter how big is the input, we're still doing this 1,000
So
times.
if it goes 1,000, it's 1.
Yeah, it's a constant, it's a 1. If it's a million, it's also a 1. In theory, you know. Do you get
What if
it?
it's just 1?
It's O1. Yeah.
What N?
N is changing, so that's ON. Got it? Yes? Okay, so now look, this is ON, right? This is ON, right? Because every time we need to iterate the numbers.
Yeah.
But how about if we are M queries? If we are M queries, what's the total complexity?
What does it mean by M?
So if they are like M queries,
Query.
M number times of queries. Like every time I give you a from and to, like an index, I give you there are n times of it. So the complexity is O, what? Altogether. M times n, right? Because n is the time we are going to iterate. We are going to calculate one query, right? Am I right?
Yeah.
Eric? And there are n times of it. So that's OMM, right? Yes?
Times n.
Yes? Does it make sense?
Yeah.
Because there are m queries and each query takes n time, right? Am I right?
Yeah.
So can we do better? Because if this numbers is not changing, if this number is still changing, we can get it, right?
Yeah.
Everybody listen. Stop it. How do we change it? How do we implement it? If I give you an example, if I know I pre-calculate this. If I say prefix I.
Prefix and suffix. Prefix and suffix.
Can you listen to me? I'm going to ask you the questions, okay? Prefix, if this
Yeah,
I,
stop.
this I, it means that I want to store the prefix sum of this. So prefix 0 equals 1. Prefix 1 equals 4. Can you tell me what it is? Prefix 2 equals 9. Prefix 3 equals 16. Can you tell me what's this?
Oh.
Is 24 and then 35.
0 is the first number, so you do the first square root number.
No.
No.
This is 4. Why is it 2?
Could I have a toilet? You add 3, 5, 7, 9. I need a toilet.
Yeah, go, please.
Yeah, 3, 5, 7, 9. 3, 5, 7, 9.
Do you get it? Because look, the first number is the sum of the first number. Yeah?
Yeah.
The second number is the sum of the first two numbers. The third number is the sum of the first three numbers. The fourth 4 will be the sum of the fourth numbers.
I didn't know you were talking about that.
Yeah. Okay. Yeah. So if I calculate this how if I want to calculate this array, what's the time complexity?
Back.
Thank you. See some.
Yeah.
What's the time complexity if I want to calculate a prefix sum array of the computer prefix sum of this array? Remember we have a for I in ON, yes. Because we need to iterate once. Listen. If we want to iterate the numbers. So why is this happening? If the prefix I equals the sum of the first I numbers. So if I want you to know, if I want you to calculate, okay, this is the interesting part, yeah? Look, if I tell you I know, if I want to know the sum of from 5 to 8, okay? Which is
5 to 8.
is what? Is 20, yeah?
Yeah.
20. So so if I have this prefix sum, so what does it equal? Prefix, if I say prefix 1, 2, 3, 4, 5, if it's 5, okay, let's do it 5, okay, equals what? 1 plus 3, 4, 9, 16,
24.
24. Okay, and then prefix of the first two numbers, prefix 2 is what? 1 plus 3, 4. So do you see the how we can get 20 from this? How can we get 20 from 24 and 4?
We subtract.
Yeah, why can we subtract? Look, prefix 5. I know the sum of these 5 numbers is 24, yeah? And I know the sum of the first two numbers is 4. Yeah? Alright?
Yeah. Why is from there not here?
Look, I want to calculate the sum of these 3 numbers. I know the first sum of these 5 numbers. And I also know the sum of these 2 numbers. So what does it mean?
We can work out these two.
Yeah, exactly. So look, I can just do this minus, yeah? So what's the sum complexity of this if we are given this? Oh what? What's better than, why are we doing this? I can just subtract. What's the complexity? What's the complexity?
And again?
Why is that? No, again, what? You're just guessing. No,
One.
oh, 1. Yeah, of course. Look, I just calculate, do the math, right? Because I know this number, I just do this. So do you see why we are doing this? We use on to calculate this prefix sum, right? And then we have on to calculate it. So if we are n query, and the time complexity would be just on, right? Right? Yeah?
Yes.
Because the constant time to look up these two values, right? Alright? Does it make sense? So we're improving this algorithm, yeah? So you see? So
We'll do the coding.
no, not yet. So look, so okay, we can do the coding and then say okay. So we
Talk about class prefix sum.
yeah, the prefix sum. So look, we are given the numbers, yeah. So we don't need to actually write that many things. Okay, 1, 2, 3, 4, 5. Let's say, and then we need to have a prefix sum. Prefix. Let's push a 0 at the beginning. Okay. Yeah, I'll tell you why I need a 0 at the beginning, and then I can just say yeah, s equals 0, and for I in lump. Yeah, look, s common sum is s plus equals I, right? Equals dumps I, right? Yeah. So now we are calculating the sum along the way. So it will be this s will be 1, 3, 6, 10, 15, right? And every time we got the s, we just push it to the prefix, just to push it to the prefix. So now after this, what's the content of prefix? Can you guess? We got the 0, and then when I in numbers, I 1, and then
2.
no. 1 plus 2, 3.
3.
And then
6. 10. 15.
okay, yeah. So that's the prefix sum, yeah. Come on. That's a prefix sum, 0 index 0. Okay, so now if I want you to calculate sum, let's say define sum, okay, and then there's a from, there's a 2, from the 2 to the inclusive index, okay, and then I want to calculate the
What's T?
2.
Oh.
I want to calculate the lambs from f to lambs t. Okay, so what's this equal? Then I can just say return. Yeah, return what? Return prefix.
Prefix and suffix.
Prefix t plus 1 minus
Prefix 2.
prefix. Let's try the prefix f, right? Does that make sense? Does that make sense? Okay, look, t plus 1. Okay, why is that? Look, let's say what was the number? 1, 2, 3, 4, 5, right? This is the original number, yeah? Alright? If I want to calculate from the index 1, this is index 1 to index 2, 3, index 3. Okay? I want to calculate the index from 2 plus 3. From index 2 to into 4, what's the answer?
2 into 4.
Yeah, 2 and 4.
6.
2 plus 3 plus 4, what?
I thought you said 2 and 4.
2 x 3 plus
9!
9, yeah. From
2!
look, this interval is 9, right?
Yeah?
Yeah. So how can we get this here?
When is it
From
done?
t 0, 1, 2, 3.
Three, four,
T is
five.
3, yeah? So I want to get the fourth value. 0, 1, 2, 3, 4. So it's 10.
When we are done.
Wait, 10. And then 0, 2, from will be 1, right? 1. So here. You see? So we got a 10 minus 1 is 9. You see? We get it. Do you get it? Remember, prefix.
Prefix
We,
and suffix.
why we
and
got the
suffix.
f? Because we added 0 at the beginning, so we don't need. We can just do it plus 1 minus f, right? Look, yeah. We don't need to. If it's the same, prefix to.
That's a 1.
Look, if it's the 1 to 1, if from and 2 is also 1 index.
The
So
time
look,
complexity
so
is a 1.
t1 plus 1 is 2, right?
Right.
So t is 1. This is 0. 0 plus 1 is 1 here. Minus 0. So look, it's 1 minus 0 is 1. Do you get it? Yes? So why are we using this? Can you tell me in one sentence, why are we using a prefix sum? And then we can end this class. Why?
Why?
Yeah? Why are we doing this? To what? To speed up the calculation, right? Yeah, because if we don't have this prefix sum, we want to calculate the range, we need to iterate these numbers. Yes?
Yeah.
We need to iterate, for example, we need to iterate 2 plus 3 plus 4.
Yes!
That's time consuming if we have a million times, or maybe 1,000 million times to do it, right?
9 o'clock.
Yes, I know.
Yeah.
But now, if I prefix sum, you just give me a two positions, yeah? Because I can just look it up in the prefix array, and I can just do a simple math. Am I right?
Mhm.
And that will be a lot faster, am I right?
Mhm.
But this is only useful if this original array is not changing, right? It's not changing because the numbers are staying the same all the time. Okay, okay, okay. So good job today. Say bye bye.
Bye. Just wait for 10 seconds.
Why?
Nothing. Bye.
Okay, that's it.